Hello friends, today we are going to learn the subjective question answers of chapter number 13, Motion and Time. Question number 1, what do you mean by the motion of a body? Answer, if the position of the body is changing with time with respect to an observer, then the body is said to be in motion. Question number 2. What is meant by vehicle A is moving faster than vehicle B? How do we find out which is faster? Answer. The above statement implies that vehicle A is covering a larger distance as compared to vehicle B in the same time period. To identify the faster vehicle, we can calculate the speed of both vehicles. The one with more speed will be faster. Question number 3. What is a sundial? How does it work? Answer. Sundials are the oldest known instruments for telling time. The surface of a sundial has markings for each hour of daylight. As the sun moves across the sky, another part of the sundial casts a shadow on these markings. The position of the shadow shows what time it is. Sundial works on the principle that the sun takes up similar positions each day. Depending on the location of the sun with respect to the dial would have different shadows by which people can extremely approximately tell the time of the day. Question number 4. What is an odometer and where is it commonly found? Answer. An odometer is used to measure the distance covered by a vehicle. Odometer along the speedometer is present in most of the vehicles. Question number 5. What do you mean by periodic motion? Give examples. Discuss the type of motion of the hands of a clock. Answer. If an object repeats its motion along a certain path about a certain point in a fixed interval of time, the motion of such an object is known as periodic motion. Examples of periodic motions are the motion of a pendulum, the motion of a spring, the vibration of a guitar string, the rotation of the earth on its axis, the revolving of the earth around the sun, the revolving of the sun around the center of the galaxy, etc. The hands of the clock move in a circle about a fixed point. Hence, they definitely perform the oscillatory motion. Since the hands of the clock are covering an equal distance in equal intervals of time, we can call it a periodic motion. Question number 6. A simple pendulum takes 20 seconds to complete 12 oscillations. Calculate its time period. What type of motion does the pendulum undergoes? Answer. The time period of a pendulum is the amount of time it takes to complete one oscillation. 12 oscillations in 20 seconds or one oscillation in 20 upon 12 is equal to 5 upon 3 seconds. Time period of pendulum. Pendulum undergoes periodic motion. Periodic motion is a type of motion which will repeat itself in regular intervals of time. Question number 7. Rohan covers a distance of 10 km by running with the uniform speed of 4.5 km per hour. Sohan runs 1.2 km in 15 minutes. Who runs faster? Answer. 15 minutes is equal to 15 upon 60 hours is equal to 0.25 hours. Speed is equal to distance upon time. Speed of Sohan is equal to 4.8 km per hour. Speed of Rohan is equal to 4.5 km per hour. Hence, Sohan is faster than Rohan. Question number 8. What do you mean by oscillatory motion? Give examples. Are all oscillatory motions periodic? Answer. If a body moves to and fro repeatedly about a mean position, it is called oscillatory motion. Examples of oscillatory motion. Part A. Oscillations of a simple pendulum. Part B. Vibrations of a mass attached to a spring. All oscillatory motions are periodic in nature. Question number 9. All periodic motions are oscillatory motion. Is this statement correct? Give reason and also give 2 examples of oscillatory motion. Answer. No. All the periodic motions are not oscillatory motions. Only those periodic motions are oscillatory motion in which the object is undergoing a to and fro motion. All the oscillatory motions are periodic motions if the object undergoing the motion does not lose any energy. Examples for oscillatory motion. Part A. Oscillations of a simple pendulum. Part B. Vibrations of a mass attached to a spring. Question number 10. What do you mean by uniform and non-uniform motion? Give an example for each. A body is said to have a uniform motion if it travels equal distances in equal intervals of time, no matter how small or long these intervals may be. Example, a vehicle running at a constant speed of 10 meters per second will cover equal distances of 10 meters every second, so its motion will be uniform. A body is said to have a non-uniform motion if it travels unequal distances in equal intervals of time, no matter how small these intervals may be. Example, a freely falling ball from a certain height covers unequal distances in equal intervals of time, so its motion is non-uniform. Question number 11. What is a speedometer? How does it work? Answer. A speedometer is a device that measures the speed of a particular vehicle at that particular instant. The speedometer calculates the speed of the vehicle at a particular instant by measuring the time it takes for the wheels of the vehicle to rotate. Since the distance moved in each rotation is constant, knowing the time each taken for one rotation gives us the speed. Question number 12. If you are resting inside a car that is moving, are you in rest or motion? Justify your answer. Answer. If you are sitting inside a car that is moving, then you are in a state of rest with respect to the car, but in a state of motion with respect to the surroundings outside the car. When a person is sitting inside a car, the person's position with respect to the car is not changing, but his position with respect to the surroundings outside the car is changing. Motion is relative. Everything moves, even though they may appear to be at rest. Question number 13. John is driving a car at 30 km per hour speed. He drove for half an hour and then he changed his speed to 60 km per hour. and draw for another half an hour. What is the total distance covered by John, and also find its average speed? John drove for the first 30 minutes at 30 km per hour and then changed his speed to 60 km per hour for the next 30 minutes. Hence, the total distance travelled by John will be the distance he covers in the entire 1 hour. Time is equal to 0.5 hour. Speed is equal to 30 km per hour. Distance is equal to speed into time is equal to 15 km. Now, new speed is equal to 60 km per hour. Time is equal to 0.5 hour. Distance covered is equal to 30 km. Total distance covered by him 45 km in 1 hour. Average speed is equal to 45 km per hour. Question number 14. The odometer of a car reads 350 km when the clock shows the time 12:30 p.m. What is the distance moved by car if at 1 p.m. the odometer reading has changed to 500 km? Calculate the speed of the car in km per minute during this time. Express the speed in km per hour. Answer: distance covered by car is equal to 500 minus 350 is equal to 150 km. Time taken is equal to 30 minutes. Speed in km per hour is equal to 5 into 60 is equal to 300 km per hour. Speed in km per minute is equal to 5 km per minute. Question number 15. Classify the following as motion along a straight line, circular or oscillatory motion. The motion of a car on a road. Straight line motion. Second, the motion of pendulum of the clock. Oscillatory motion. Third, the motion of a child on a seesaw. Oscillatory motion. Fourth, the motion of train on a straight bridge. Straight line motion. Fifth, the motion of the hands in a clock. Circular motion. Thank you, friends. Bye bye.